Hi, welcome to Lucky Maths. Today's topic is perimeter. What do you mean by perimeter? Perimeter is the surrounding length of a shape. Look at the table here. You have four familiar plane figures: rectangle, square, triangle, and a circle. How do you find the perimeter of a rectangle? 2 times length plus breadth. Or you can add all four sides here. Then square. You have four equal sides. So to find the perimeter of a square, you have to multiply length of a side by 4. Or you can add all four sides here. Next triangle. You have 3 sides. The sum of the length of the 3 sides make the perimeter of a triangle. Then you have a circle. If you know the radius here, to find the circumference of the circle, you can use this formula 2 pi into radius. Okay. Now you can try review exercise. Okay kids, our next topic is sect of a circle. What is the sect of a circle? The portion of a circle which is surrounded by 2 radii and 1 arc length, which is the part of the circumference, is called the sect of a circle. Look at this circle. Here AC and BC are AD and AB is the arc length. Theta is the angle between these two radii. Next topic, 1.1. Finding the arc length of a sect of a circle. Look at this portion. Look at this sector. Then you have 2 radii here, that which is R, radius R, and arc length. To find the arc length of a circle, you can use this formula. The angle between 2 radii, theta over 360 into 2 pi r. If you know the theta angle here and the radius, you can find this arc length. Okay kids, now I'm going to explain you example 1. Question 1. What fraction of the circumference of the circle in the figure is the arc length of the shaded sector? So, look at here. What is your angle here? It is 45. Full turn is 360. So, how do you find the answer for question number 1? Answer is 45 over 360. You can simplify this one furthermore. 45 times 8. This is the answer for 1 over 8 is the answer for question number 1. Then second, read the question carefully. Find this arc length. So how do you find the arc length? We have to use the formula there. What is the formula? Theta over 360 into 2 pi r. Okay, now arc length. Arc length is equal. What is theta here? that is 45 over 360, or if you want you can use here 1 over 8. I write here 45 over 360, then 2 pi is 22 over 7 into what is r there? 7. This 7 and 7 cancel. Then this is 1 over 8. So again you can simplify 2 times 1, 2 times 4. So then 22 over 4. 22 over 4. You can simplify this one furthermore. 5.4 times 5 makes 20. Then you have another 20, which is 5.5 cm. Now kids, I am going to explain you example 2. Read the question. The arc length of a sector in the figure is 44 cm. Find the radius of the corresponding circle. Right. Now, what is the formula for the arc length? That is theta over 360 into 2 pi r. R is the radius here. I took here r. R is the radius. Okay. Now, that is equal to 44. Arc length is 44 hour. What is theta here? That is 120. 120 over 360 into 2 pi is 22 over 7. R, we don't know R, we have to find that, equal to 44. Now you have to simplify this thing. 120, 360, 1/3. Then what you have to do here to simplify this thing, you have here 2 times 22, that is 44 r over 7, and you have 1/3 there, equal 44. Then what you have to do, here you have 3 times 7, which is 21. If you multiply both sides by 21, this way linear, this equation. So I multiply this equation by 21, 44r, then 21 equal 44 into 21. So we cancel this 21 here, and to subject r, we have to divide both sides by 44. Then r equal 44 into 21 divided by 44. Then 44, 44, we cancel. Then your answer will be 21 cm. The radius here is 21. Okay, kids. Next, I'm going to explain you example 3. Read the question carefully. The arc length of a sector in the figure is 11 cm. Find the angle at the center of this sector. You have to find the angle here. This angle, we put it theta. This one you want to find. Arc length you have, that is 11 cm. Okay. What is our formula now? Theta over 360 into 2 pi r. That is the arc length, which is equal to 11. Now what is our theta? We don't know. We have to find that one. Theta over 360 into 2 times 22 over 7. R we know that is 9 equal 11. Now we want to make this simple. Then 9 times 4, 40. We can cancel this one 2 and we have 20 here. And furthermore 2 times 11 and 2 times 10. So you have here left hand side you have 11 theta over you have 10 into 7 that is 70 equal 11. If you multiply both sides by 70 you have 11 theta equal 11 into 70. So to find theta you want to divide both sides by 11. 11 into 70 divided by 11, this will cancel, and your angle theta is equal 70 degrees. Okay kids, now you can try exercise 1.1. Our topic is now 1.2, finding the perimeter of a sector of a circle. Look at this sector. Here you have two radii, one arc length. The perimeter of the sector equal to arc length plus radius, which is equal to arc length plus 2 times radius. Now look at the example 1. The figure denotes a sector of a circle of radius 21 cm with an angle at the center of 120 degrees. Find its perimeter. To find the perimeter of this sector, we have to find this arc length. So how do we find the arc length? We have the formula theta over 360 into 2 pi r. This is the arc length plus 2 times 21, which is the radius here. So what is theta? Theta is 120 over 360 into 2 times 22 over 7. Our R is 21 plus 2 times 21, 42. Now you can simplify this one. That is 1/3, and you can simplify this one. 7 times 3 and 3 again cancel. You have here 2 times 22, which is 44, plus 42 is your perimeter of the sector. That is equal to 86 cm. Okay kids, now I am going to explain you example 2. Read the question carefully. The perimeter of a sector which is 2/3 of a circle is 260 cm. Find its radius. Here you have the perimeter of sector. So what is the perimeter of sector? 2r plus theta over 360 into 2 pi r, which is the arc length, that is equal to 260. But they have given 2/3 of a circle. So then we have to write here 2r plus 2/3 of a circle, 2 pi r. That is equal to 260, which is the perimeter of the sector. So now 2r plus 2/3 into 222/7 into R, we have to find that equal to 260. Now 2R plus, now we have to simplify this thing. Here numerator you have 2 times 2 into 22. 44 into 22 you have 88. R over denominator you have 3 times 7, that is 21, equal to 60. So you have to make this equation linear. So when you multiply all term by 21, it will be linear. So then 2 into 21 R plus 88 R, 21 will cancel, equal 260 into 21. Now 2 into 21, 42 R plus 88 R equal 260 into 21. Now you have to add 42 R, add 88 R makes 0, 4 plus 8 to 120, 130, 130. R equal 260 plus 21. Now to subject R, you have to divide both sides by 130. 260 into 21 divided by 130. You can cancel 130, 260, that is 2. Then your R is 42 cm. Now you can try exercise 1.2. Hi kids, our topic is 1.3, the perimeter of plane figures containing sectors of circles. Example 1. The figure illustrates how a semicircle has been joined to a rectangle of length 20 cm and breadth 14 cm such that the breadth of a rectangle is the diameter of a semicircle. Find the perimeter of this figure. Here you have a rectangle and a semicircle. To find the perimeter here, you want to find, you have this length that is 20 and you have this length that is 14. This is also 20 and you want to find the semicircle length. So, you know the circumference of a circle, that is 2 pi r, then semicircle, that is 2 pi r divided by 2. The length, the perimeter of semicircle, I draw like this, that is equal to 2 pi r divided by 2, 2 to cancel, pi r. So what is your r now here? R is here 7 cm because this length is 14 divided by 2, that is 7. So then 22 over 7 into 7. 7, 7 cancel. You have 22 cm. So that is the perimeter of semicircle. So then the perimeter of this figure, total perimeter is equal to 22 and you have 20 and you have 14 and you have 20 again. You have 1, 2, 3, 4 sides. So what is that? 20, 20, 20, you have 40 and 62 plus 14 makes 76 cm. Okay. Now I'm going to explain you example 2. The figure represents a square lamina of side length 15 cm. If the shaded sector AGB and the triangular portion GEF are cut out, find the perimeter of the portion BCDFG that is left over. So here you have a square. So you can find AG that is equal to AB here. So then you can find BC and FD. Again you want to find GF and this BG length, that is arc length. So to find GF, you want to apply here Pythagoras theorem because this is a right angle triangle. To find GB, you want to apply, you are already known how to find the arc length of a circle. Okay, now we'll start now. So AG is equal, AG is 15 minus 8, that is 7. So AB is equal 7. So then you can find BC. BC is equal 15 minus 7, which is equal to 8 cm. Now FD. FD is equal 15 minus 6, which is equal to 9 cm. Now we want to find GF. This GF. So this is G and F, E. This one is 8 and this is 6. So here we want to apply Pythagoras theorem to find GF. So then GF is equal square root of 8 squared plus 6 squared, which is equal to square root of 100, that is equal to 10 cm. Then you have to find this arc length. Arc length BG, that is equal to 90 over 360, because this is a quarter circle, into 2 pi, r is here 7. You can cancel this thing now. 1 over 4, again 1 over 4 into 2, 22 over 7 into 7. 7 here, 7 cancel. Then 4, 2, 1, 2, 2 times 11. So then BG is 11 cm. We can find the total perimeter. Now the perimeter BCDFG is equal, what you have to add here, BG that is 11 and BC that is 8, CD that is 15 and DF that is 9, FG that is 10. You have 1, 2, 3, 4, 5 sides. Okay. Now when you add all these three, 9, 5, 14, 9, 23, 3, 4, 5, 53 cm. Your total will be now 53 cm. Okay kids, now you can try exercise 1.3.